So that's me. I'm Christopher Gallo. I work at SoftLayer. I've worked there for about 10 years now, starting back in 2005. I've worked in a variety of departments, starting off in tech support, answering phone calls, helping people troubleshoot their web servers, a little bit in professional services, doing some of the more complicated tasks for customers, a little bit in development, and now I'm a technology evangelist. And so that's basically given me a very good idea of what some of the big problem points are for a lot of our customers, a lot of deployments. And so I'm going to help kind of relay those to you a little bit today to help make your deployments a lot easier, to learn from all of our customers' mistakes that I've got to help them with. That's my Twitter handle. If you'd like to follow me, feel free. I'll generally just post stuff about what conferences I'm going to, and afterwards what I learned and some interesting things that you guys might want to look at. That's my GitHub account. I usually post examples of how to use SoftLayer with a variety of languages, but also contribute to a bunch of other projects. SaltStack's a great example. So just a little bit about SoftLayer. We cover a huge number of customers. We've got over 100,000 servers spread across 24,000 customers with 23 million domains. And this gives us a very wide variety of infrastructure types to pull information from and that we have experience with. And so what I'm going to be talking to you guys today is about bringing agile methodologies to your deployment practices. So agile principles do not just apply to programming. They apply all the way to deploying your infrastructure. One of the key agile principles, especially for deployments, is working software is delivered frequently. At SoftLayer, we deploy code to production usually about twice a week. And this is pretty rapid for most companies. And we need to deploy this software without breaking anything, without having any customers notice. And this can be very difficult if you don't have a very fine-tuned deployment process. So some of the problems with deploying is we need to be able to deploy quickly. From the get-go to having your code on production, it needs to be as quick and as fast as possible so that you minimize the chance of anybody notice that you're doing a maintenance. We need to be very consistent with our deployments. So what this means is when you take code from your staging environment and put it into production, it needs to work the exact same way every single time. A lot of the problems I see with failed deployments is that there's an inconsistency between the staging environment and the production environment. And so when the code gets deployed to production, that inconsistency will generate errors and cause problems. We also need to deploy across a wide number of devices. So you might not have just a variety of Red Hat boxes. You might have CentOS boxes. You might have Ubuntu, Debian servers, Windows boxes, mobile phones, you name it. We have to be able to deploy across all these devices at the same time, all without causing anything to break. All of this needs to be done with minimal downtime, because the last thing you want to do is have your customers notice that you're fixing something, that you're upgrading something, because that gives them a pretty bad experience. And in the worst case scenario, if something does break, we need to be able to roll back quickly. So this button here is the promised land of DevOps. Your goal here is to press this button, maybe go get a cup of coffee, and when you come back, your changes have been deployed, nothing broke, nobody noticed, and you can go on with the rest of your day without having to worry about all the stresses that deploying code can bring to you. And this is kind of where I want to get you guys at the end of this presentation. So just a little cautionary tale before we start, because some of you might not think a broken deployment is that big of a deal. This is an SEC filing from Knight Financial's deployment that caused them to go bankrupt in a matter of 45 minutes. So during the deployment of new code, however, one of Knight's technicians did not copy the new code to one of the 8 SMARS computer servers. Knight did not have a second technician review this deployment, and no one at Knight realized that the PowerPeg code had not been removed from the 8th server, nor the new RLP code added. Knight had no written procedures that required such a review. This is an excerpt from Doug Seven's blog. The URL is right there. Highly worth reading. But to summarize it for you guys real quick, the PowerPeg code that was left on one of the 8 servers was basically an old, depreciated, dead code library that would make trades for Knight Financial. It was on all of these 8 servers, but scheduled to be removed because the new RLP code was using one of its flags. And if the code was there, the PowerPeg code would start making bad trades, which is exactly what happened here. And so these machines, as you can imagine, make trades very quickly in high volumes. And so once this code went live and that 8th server's PowerPeg code started activating again, it started making bad trades at a very rapid fire rate. Knight had no way of figuring out what was going on, what went wrong, what might have changed. And so in these 45 minutes where they were still trying to figure out why they were making so many bad trades, they lost $400 million in bad trades, which caused them to go bankrupt. Now, all of you probably don't have this problem specifically. A bad deployment for you might just be a little embarrassing. Your coworkers might make fun of you. But we still want to avoid that. So the first thing we need to do is we need to get ready. Usually I like to take a deep breath before I do any deployments. Just kind of center yourself, calm yourself a little bit, because deploying code can always be a pretty frustrating experience. But I also want you guys to make a checklist. This seems pretty basic, very rudimentary, no technology at all. You can even write this checklist on a piece of paper if you want. But it is, in my opinion, one of the most important things in deploying code. Dr. Atul Gawande has written a book about checklists. In his book, he describes specifically checklists being introduced for surgical theaters for a specific type of surgery. Surgeons are a very proud profession, much like ourselves. They've generally felt that having a checklist was very, I guess, demeaning. They felt that it was making their job too easy, I suppose. Yeah, it's ridiculous to think about. But we generally refuse to follow a checklist as it kind of takes some of the arcaneness and magic out of our jobs. But what Atul found was that it reduced complications in surgeries by up to 40% and deaths because of those complications by 70%. Just having a simple checklist, which are incredible numbers. And this checklist is not very detailed. It's simple things like, did the surgeon wash his hands? Has the patient identified themselves by name? And is the incision point actually marked on the body? Just simple things like this drastically reduces complications in surgery. And in our profession, they can drastically reduce errors in deployments. If Knight Financial had a checklist, they probably would have known that Server 8 hadn't actually been upgraded because it wasn't marked off the checklist, and they might still be in business today. So, yeah, go ahead.
I read that book, and I started using checklists, not for deployment, but for things, and it is fantastic.
Yeah.
I've cut down certain types of errors from about 20% to 0.
Yeah, absolutely. Yeah.
But I'm curious about for deployment, do you advocate doing a general, this is how, or a checklist for deploying code in general, or creating one for each?
It depends on how. So the question was, do I advocate making a checklist for each deployment or for it in general? And so I'm going to say it's going to depend largely on how different each deployment is. So for SoftLayer, our deployment processes are very similar. We've got code, it goes into a repository, it goes out to our servers, and it's very simplified, but that's largely our process. So for us, I'd have one checklist for every deployment that we do, since they're all very uniform. I spent a little bit of time at another company, a security company. Their deployment processes were all very unique depending on what they were deploying. And in that case, I'd advocate a general checklist to get you started, but fill in the specifics for what different use cases there might be. And those would generally be found out in testing. And so here's a great example. Here's what I would use as a checklist. This is a site called Trello, Trello board. So obviously you can write down your checklist on a piece of paper, but if you have more than one person in your group, having a board like this kind of helps your group come together and they can all see what's going on. So for my deployment in this specific case, I've got 3 basic what's called pause points in my process. And I'm not going to go to any of the new points until all the steps in the previous section are cleared out. So I've got a pre-deployment section with a variety of steps I need to do. I need to make sure all my code's committed. I need to maybe create a package for my application. I need to actually make sure it's got tests, verify if there's any new dependencies, and then verify if I've got any new database schema changes coming down the line. And with a Trello board, I can assign users or groups to each of these tasks to make sure I know who is responsible for getting them done. You can have due dates, so maybe they're all due on deployment date. Maybe you got to make sure some of them are done beforehand. And this is going to help organize your deployments in a very team-oriented fashion. And so we got to then we have the deployment process. So this is the part where your code's actually being changed in production. And then afterwards, you have your post-deployment process, which is just making sure everything actually worked the way you expect it to. And if anything went wrong, this is the point where you'd either roll back or make another release to fix it up real quick before anybody notices. And so if we drill down into one of these tasks, this is what it's going to look like a little bit. So in this, I've got a checklist inside of my checklist for each of the servers I need to deploy code to. I got to check them all off. You could have your descriptions. You got a little progress bar. It's all pretty neat stuff. And it's all pretty low tech, too. And so just having this point, like our friend mentioned, will kind of help take away the pain of missing servers, of forgetting to update that one config file that got changed, of forgetting to update the database schema on the backup database server, and those sorts of mistakes that we really shouldn't be making, and that we're only making because we got busy, we forgot about them. And so the checklist helps you remember. So now we need to make it easy. So we've got our checklist. We know what we need to do. We know where we need to deploy. Now we need to make the actual process easier, because right now it's still very manual. And so here's a couple ways of doing that. A lot of the times I see very complicated Perl scripts being used. So generally they seem like a good idea at the time, right? Perl scripts are pretty easy to bang out, and they work pretty effectively. But the problem is, Jeff is the only guy at your company who knows how to write Perl. And once he leaves, you have to reinvent your deployment process again. So probably not the best idea. So we're going to need to find something a little better. I see direct code checkouts a lot. So you'll just go to your web server, do git update. It pulls out on your code. That's pretty easy to do. The only problem is rolling back git updates, in my experience, have been a pretty big pain, especially on web servers. It's still very manual, and there's no way to handle all the system dependencies that you might have to deal with. Getting in your application to an actual system package is one of my favorite ways of deploying code, because it handles easy updates. You can put your package in a repository server. Just do apt-get update, for example. It'll pull down your application, any configuration changes, any dependencies, all of that in a very standard, very easy-to-use system. That's pretty much on every single box already. The only problem with this is building the package is rather unpleasant if you've never done it before. And it's, again, another service that you have to maintain, so you do have to watch out for that. But it does make the deployment process a lot easier, especially from a conceptual point of view. So when you want to update your code, you just have your update server, pull it down, and you're pretty much ready to go. Images are generally going to be for your more complicated deployments, or if you need to deploy it across a wide range of servers. The great thing about images is you get a fixed state for your system. So in your testing environment, you'll build the image, you get exactly how you want it, and then you just spin up new images, spin down the old ones, maybe move your DNS over to the new images, and you'll be ready to go. In this way, you don't have to worry about updating code, having changes not get applied correctly. Your image is exactly the way you want it, and it's very almost sure to work. Docker is another great piece of technology. It's somewhat like images and a little bit like Git, all kind of merged in together. If you're not familiar with Docker, what it basically does is it lets you take your application, all of its dependencies, all of its resources, put it in a Docker container, and then you can deploy that container across any of your Docker servers. What's great about this is Docker has a lot of pre-built examples for you. I do a lab a lot of times to demonstrate the power of SoftLayer, and I use Salt and Docker to spin up a huge number of instances for my labs, all with just a few clicks of a button. And they always work exactly like I expect them to because of the power of Docker technology. The only problem that I don't care for is they run in a Linux container, which, although are very lightweight, it's still a small level of abstraction from the core operating system. And if you're doing anything high performance, that might be a little bit of a problem for you. But for web servers, Docker's great. And it's not quite a standard yet, not like packages and images are. So there's still a lot of movement going on in the Docker community. Still a lot of changes happening that you're going to have to watch out for. So now we need to go ahead and make the computer do it. Because if you've got more than a couple servers, logging into each one, updating it all, is going to be a huge pain. And this is what we built computers for in the first place. So I'm sure you all know we're at Salt Conference, so you're all pretty familiar with SaltStack, I hope. But this is going to manage all your configurations for you, which is pretty much, in my opinion, SaltStack is like having a new sysadmin on my team that I don't have to pay, I don't have to go out for lunch with them, and he's always here on time. I just say, hey, SaltStack, go deploy my code, go run these commands, and it just goes and does it without giving me any grief about it. So it lowers the cost of server administration because it can help you run a large number of servers with a much smaller team. It's very reliable. It's going to do the same command on every server just like you specified. The best part is the code becomes your documentation. I'm sure all of you had experienced at least one point in time having to deal with a server in production that wasn't actually documented. You maybe don't know what it's doing. You maybe don't know what service is running. And the documentation you do have is incredibly vague. You might have just one page. It's got the server name, its IP address, and it says, do not reboot, very important. But it doesn't tell you what it's important, right? It's not telling you what configuration files you need to update, what packages are installed, or any of that. And so this is where Salt, I think, really shines, is because if you manage all your deployments consistently with Salt, and everything that's installed on the system was installed through Salt, it'll be in your SLS files. So you can look at the specific server. You can say, oh, it's got these dependencies. It's running these commands. It's running these services. And if you want to make any changes, you make it change to the documentation first, have Salt deploy it, and that way any future generations can come look at what you've done and see exactly what's happening on that server. It allows for continuous integration and deployment. So a lot of the testing environments I've seen, especially for complicated deployments, the new trend is to just spin up an entire mirror of your infrastructure, usually with low-cost VMs. You'll have Salt make sure that infrastructure has all the updates it needs. And then you test that infrastructure specifically. So if it passes all your tests, you spin it down, and then you deploy to production. If it fails, you keep it up, you fix what was wrong, and then you try again. And so this is going to make consistency very important to you. So your deployments are you're going to know exactly what's going to happen when you deploy your code. There's going to be no guesswork. You're not going to have to worry about someone missing a single server and bankrupting your company in a couple minutes. So this is kind of where build servers start coming in. Spinning up entire infrastructures is a lot of work. And build servers are going to be able to do that for you. They're going to be able to manage all your code. It's going to pull it in. It's going to say, hey, I want to spin up this specific infrastructure. It'll spin up all the servers. It'll talk to Salt. It'll say, Salt, I need you to manage all these servers for me with these sets of configurations. It'll then run all the tests for you. give you some nice statistical feedback. Say, hey, these tests work, these tests didn't. And here's how good we should feel about this deployment. And so here's a couple of examples. That little circle logo, that's Atlassian Bamboo. So if you're already using Bamboo for any of your code management or documentation, I'd recommend it, as all their Atlassian products work pretty well together. They're nice, and they mesh very well together. We've also got Anthill, which is a pretty neat project I've seen a lot of people use. TC Jenkins is probably the most popular at the moment. It's what we use at SoftLayer to manage all of our deployments. We've got a very complicated Jenkins setup to manage everything. And then there's BuildBot, which probably you haven't heard of. It's my personal favorite at the moment. Like Salt, it's a free open source project written in Python, which was essentially the choosing factor for me. Having it be open source and Python makes it a great choice for me personally. The only problem with it is it's a little rough around the edges, and it's more of an actual framework. So you're going to actually have to write code to make BuildBot do what you want. But that's what I'm going to show you guys today. So if you guys want to use Jenkins or Bamboo, you're going to be a little bit on your own, but the same principles are going to apply across any of these. So here's a quick code snippet. This is, in BuildBot technology, this is the builder. So when I launch a job, BuildBot is going to do exactly what I tell it to here. So I've got two steps. I've got the high state step and the checkout step. The high state step is basically saying, Salt, put all my servers in the high state to make sure they're all the configurations are updated. And checkout is just checking out all of my new configuration changes. So I keep all my Salt configs in a Git repo. That way I can know what gets changed, when it gets changed, and have all that tracking management built in. And so I add the 3 steps to the builder factory, and add that factory to BuildBot. So when I press build, it's going to run these 3 steps from the factory. So the first step, I'm going to make sure Salt's already in a high state. I want to make sure nobody's gone in and nobody's changed anything. Everything's exactly how I expect it to be. Because if something went wrong and you try to deploy your new step over it, you might get some false results. So if this step fails, the whole step will bail out, and you can go see why your servers aren't in the state you expected them to be. Then we just check out the code, and we apply the high state again, this time with any of the new changes we pulled down. And here's kind of what it'll look like in the GUI. It's pretty messy. Like I mentioned, it is a little rough around the edges, but that's kind of what you get with free software sometimes. So here's basically all my builds. I've got some successes, some fails. I can force a build manually, or a build will trigger anytime I make a change to the master repo. And this is kind of where the push button starts to happen, right? If I want to update all my changes, I just press this force build button, and it'll update all my infrastructure without me ever having to do anything other than press that one button. And I think that's a pretty impressive feat for your DevOps team to do. So here's kind of how I envision the development process to go in my imaginary company that I've been kind of talking about. So in the green guy, he's our sysadmin. He's responsible for all the configuration changes. So when he needs to make any change to the systems, he's going to make it to the Salt stack repo that he's got set up. That's going to have all his configurations in it. And then the build server will detect those changes, deploy them if need be. It can be forced to build. And all the sysadmin has to do is commit his code to the repository and press the button. Then we've got our developer guy in orange. He has a very similar process. He'll commit his code to his application repository. The build server will detect it. It'll build a package for him. And if needed, it'll also update the Salt repository, say, hey, I want to deploy this new package now. And then it'll go out and deploy it to whichever environment you specified. So if we're building off master, we'll probably deploy to the blue production environment. If we're using a branch, for example, maybe we'll have a tagged release version. We'll deploy to the red staging environment. And this is going to be all managed by the Salt Cloud SoftLayer module. So Salt Cloud, which I'll get into a little bit later, is what's going to be responsible for spinning up all these VMs for you, which is a pretty cool feat for Salt. And then if it's just a testing thing, just a little quick test, we'll probably want to use the Salt Cloud LXC module, which is also pretty cool. This will just be all built on your laptop, so you don't have to incur any server costs or anything like that. And so as a developer, this is great because you can have your entire production setup on your laptop. You might not have all the production data, but you'll have all the resources. You'll probably have all your tables defined. And this will give you a good example of what's going to work in production and what's not. And this is also a great way for your developers to get those 16, 32 gig RAM laptops they've all been requesting for, because spinning up an entire infrastructure on a laptop is going to be a little memory intensive, depending on the size of your application. But this is going to give them a very good idea of what changes they're going to need to make to production to get their code working. So this brings us back to consistency. Each one of these steps along the way has the exact same configs on them, so everybody's on the same page. Nobody's installed any different packages that nobody knows about, and you're not going to get bit when that code gets to production without the package.
Question.
Yes?
Do you have a separate life cycle from your salt management going through stage and your applications, or is it just kind of clumped together and rolled out?
Generally, I would clump them together and roll them out. So at SoftLayer, our idea is we have scheduled updates. So twice a week, on the same day, we update our code. So if you got any configuration changes, those will go in. If you got any app changes, those will go in. And so you'd only get to be able to deploy them as one of those 2 days. So either way, they all get deployed in the same process, I guess. So this is where SoftLayer kind of comes in. This is an example of one of our data centers, all nice and pretty. One of the things you won't notice in this picture is any people. Generally, our data centers have very few people actually in them. The only time someone needs to go in here is to maybe replace a hard drive, maybe upgrade a couple servers. But in general, it's pretty quiet. And due to this level of automation, that's how you can use SoftLayer to spin up these test infrastructures for yourself. So instead of waiting weeks or months for a new server to come in, you just order one with us, and it's ready in a couple of minutes, maybe a couple of hours, depending on what kind of hardware you ordered. So SoftLayer, our business is basically selling servers. And we do that in a couple different ways. So obviously, we have bare metal servers. So if you need performance, if you need gigantic boxes, you can just simply order a bare metal server from us and have direct access to the hardware, which is one of our differentiating points from a lot of our competitors like AWS or Azure, is they all do VMs. But sometimes you do need that gigantic server to run your database or any huge processing nodes you might have. We've also got a private cloud offering, which is essentially the same thing as our public cloud. You get VMs on a hardware node. The only difference is with private clouds, you're the only tenant on that node. So you don't have to worry about any noisy neighbor problems, and you know exactly who's running what on your node. Public clouds, these are just your general VMs, pretty standard. They run on Xen. We can spin these up in about 10 minutes in the worst case, sometimes a lot sooner depending on what kind of size you requested. Then hybrid clouds, that's usually what's popular these days. So you use bare metal servers for some things, public cloud for other things, private clouds for everything else. And you'll mix these up in just any kind of way that's comfortable for you. And so what's important to note about SoftLayer is all of these images, they all share the same backend network across all of our data center sites. And all the traffic across our backend network is free of charge, even going from site to site. So if you're doing backups, if you're doing disaster recovery setups, you don't have to worry about replicating huge amounts of data from Dallas to London, for example. And this is kind of our network map at the moment. A couple of these sites haven't come online yet. The one in Shanghai, the one in India, and the one in Sao Paulo. Those are all scheduled for later this year at some point. But all the other sites are upline and operational. So the white and yellow dots are going to be our actual data centers. These are going to have between 4,000 and 12,000 servers in them, all of which are essentially identical to that picture I just showed you, which is one of the great things about SoftLayer's deployment. All of our data centers look almost identical. You could take a DC tech from from Dallas, for example, drop him in Sydney, and he probably wouldn't even know the difference. Each of our data centers is connected to each other with our private and public networks, which gives us a huge internet backbone for you to transfer all your data across from. We also have these little red dots, which are called points of presence. These are essentially entry points into our network without actually having a data center at them. So if your customers, for example, are in Dubai, they'll connect to our Dubai point of presence, and from there, they'll go through our controlled network into our data centers to your servers. So they don't have to worry about shady telecoms in that region or other connecting areas, routing their traffic weirdly, being slow, having high latency. Since we control all the network from all of our servers, we can make sure it's very fast and very reliable. And you can spin up servers in any of these data centers pretty much exactly the same. The only difference is specifying the name of the data center you want to spin it up in. So here's an example of Salt Cloud like I mentioned earlier. If you've never used Salt Cloud before, it's a pretty cool feature of Salt. It's got 3 essential components to it. So the first one is you have the provider. Salt's got a wide number of providers, SoftLayer being one of them. Here, all you really need to specify is some master configuration. I'm going to say my master server is at this host name. I'm going to specify my SoftLayer API key and username. That way it knows which account to actually build the new servers to. And then I just say the provider is SoftLayer, and Salt knows what to do with that from that point. Then I've got my profile. This is going to be specifying, when I spin up a new server, what actually physical parts it's going to have. So this server is going to have, it's going to specify the My SoftLayer provider, which I named up there. It might be a little hard to read since it's kind of in a weird red color. Sorry about that. I'm going to specify my provider. I'm going to specify an image. I'm going to use the Ubuntu latest image. SoftLayer has a huge number of images, so whichever operating system you want, you can just specify it here. I'll have 1 CPU, a gig of RAM, 100 gig disk drive, and a whole bunch of other options down there. The one at the very bottom is an image. So I've created, this is an example from the lab I give, and I've got a very specific image for that lab that has a bunch of pre-built commands in it. So whenever I spin up a Salt Cloud instance, I want it to be of that image type. And then lastly, you have a map. The map is what you're actually going to tell Salt to spin up. You're going to say, Salt Cloud, I want to use this map file to spin up a bunch of VMs. In my case, I've got 2 VMs that I'm going to spin up with the Ubuntu Dalo 9 profile. And they've got a whole bunch of varying, these are all Salt-specific configuration parameters. So I'm specifying a grain here, a node type. And if you're familiar with Salt, these are ways that Salt can categorize and differentiate servers between each other. I'm specifying the host name at the top, so both of them are going to be called MinUno1 because I forgot to change it to MinUno2. But you kind of get the idea. Is that if you want to spin up a whole bunch of web servers all at the same time, a Salt map would be a great way to do that. You can also spin up images directly with SoftLayer. So this is an example of our SoftLayer command line utility. It's an open source Python project available on GitHub. And when you install it, you can install it with pip or easy install. And it'll give you this SL command that is a direct access into the SoftLayer API without ever having to learn any code. So I'm essentially doing what I was doing with that salt map file, is I'm creating a VM in the data center SJC01 with a host name, a domain name, and all my other options. And this is an example from my lab. I've got a custom bash script that continuously hits our API to check the status of my VM. And it'll give an output similar to this. And you'll see each of the steps our VM goes through on its way to being provisioned. It'll have a host assigned to it. It'll copy over that image template I specified from our SAN. It'll power it on. It'll install some additional services, and then my VM's ready. All within a couple minutes with just one quick command line, and now I've got a new server for myself. And our command line tool can create create hardware servers too. It can manage most of our services all through a command line. And so here's a Python example. Here's how I would do the exact same thing with a bit of Python code. So you can get in a lot more detail with the Python code, obviously. Do a lot more interesting things. You can order more than one server at a time if you wanted. And these are all going to be available on my personal GitHub page or SoftLayer-specific GitHub page. You can all find a wide number of examples on using the SoftLayer API to manage all of our infrastructure. So now we need to go make this happen. So I've talked a lot, hopefully giving you guys some pretty good information. So when you go back to work, Monday or Friday or whenever it is, just take a deep breath and think about how you can turn your deployment into an actual checklist. Usually, in practice, I've seen this be a little bit of an iterative process. You'll try it once, you'll deploy, you'll realize you missed a bunch of steps, and go back and do it again. And eventually, after a few deployments, you should get this checklist to a point that you could hire a new guy off the street, give him the checklist, and he could hopefully deploy your code for you. Check out some of the new tools I mentioned. Learn how to automate your build process if you have not already. Automate the deployment and testing process. And then hopefully after that, enjoy your stress-free deployments. And you can get to work on looking at more cool new tools rather than worrying about if your next deployment is going to break or not. And that's all I have for you guys. Thank you very much for your attention. I've got a few minutes for some questions if we have any. Yes, go ahead.
So when you deploy to your staging environment and you deploy to your environment, ideally you want 2 buttons. Do you manage that through Salt environments? Do you have specific, how do you differentiate that?
So the question was, how do I differentiate my production environment from my testing environment? So Salt environments is a great way to do this. In my examples, I only had one deployment option, which was always production. So I've seen a lot of people either use Salt-specific environment options. You can also use different Git methods. So I might have a testing Git branch, and I'll deploy my Salt code off that Git branch. And when it comes in master, that's when I deploy it to production. So I've seen kind of both of those ways done. I personally like the Git method because that's what I'm more familiar with. But I definitely think the Salt environment method is a lot safer, I'd say. They're a lot more well-defined anyway. Anybody else? All right, well, thank you all for coming. I hope you guys enjoy the rest of the conference. Thank you very much.